Hey math people, this one goes out to you, Tommy boy. Let's derive Bayes' theorem using conditional probability as a start. So definition of conditional probability, probability of A given B is the same thing as the probability of A and B all over the probability of B. Who's to say you can't write additionally the probability of B given A? No one's to say we can't do that. We can write it, we shall. So let's write the same thing for probability of B given A. Two conditional probability statements. How about we solve for probability of A and B for both statements? We're gonna multiply the left equation by probability of B. We're gonna multiply the right equation by probability of A. What's nice is, let's just take a look at just the left equation here. When you multiply this right hand side, divide by probability of B and multiply by probability of B, these cancel. And what are you left with? How about we bring this probability of A and B up front, and that is equal to the product of the probability of B times the probability of A given B. The way this simplified on our left equation will simplify the same exact way on the right, just all the A's and B's switched. What do we have going on here? I have the probability of A and B is equal to this thing, and the probability of A and B is equal to this other thing. This is just another way of writing that intersection probability. Hey, I can use some transitive property. These two things must be the same. Now we're just one step away from Bayes' theorem. Now it totally depends on what you want to isolate here. Let's isolate the probability of A given B and write our definition that way. Cross it out on the left, rewrite it on the right. Which leads us to Bayes' theorem. As easy as 1, 2, 3. This equation is my Baye. So after in this video, please continue to math on, and I will do the same. I'll see you in the next one.
Hey.